As soon as we turned off the switch, the bulb turned off, which is very basic. But the electricity behind this switch is traveling at almost the speed of light. What happens to it after stopping it suddenly? We don't really care about it. But this 400 kV line here, we care a lot about it. Can you imagine how the switch to turn off this line will be? This is an isolator that is attached to close the 400 kV line, which works exactly like our home switch. But when the isolator is removed to close the line, you will see that we have removed the isolator connection. Still, there is a connection made with such a heavy sparking through the air. Now the contact of the isolator will start melting with such heavy sparking. The line is 400 kV now, the voltage of the transmission line is up to 1100 kV. So the isolator is definitely attached to the line, but the on-load line cannot be broken. So a powerful device was made to break the line, which is called a circuit breaker. It can break any line from 132 kV to 1100 kV with complete safety. And even if there is a fault in the line, it trips automatically. The circuit breaker you are seeing is a circuit breaker. It has the same mechanism for all three phases, but this mechanism operates in different bushings. The upper terminal comes from the main line and connects to the upper terminal. And the output of the circuit breaker comes out of the lower terminal. Now the mechanism to break the circuit is installed in between these two terminals. The upper terminal is absolutely fixed and cannot be moved at any time. The road that is stuck here is copper. There is also a copper road in the lower terminal that can move. This road is hollow from the inside and makes contact with the upper terminal. Lower contact cannot move itself, but there is a mechanism to move this copper road. The moving contacts here operate from outside. Let's assume that the line is on and the circuit breaker is in contact. There are two conditions here. If there is a fault in the line or we manually close the circuit breaker, then the line breaks in both the conditions in the same process. This mechanism has two springs and both the springs are loaded. Below is a relay with the plunger system. A current transformer is also installed near the circuit breaker. So whenever there is a fault in the line, high current will flow from the current transformer. And the current transformer tells the relay that more current is flowing than the circuit breaker. The breaker needs to be tripped. A small question for you friends. Here the current transformer operates at extremely high current. And the relay in the circuit breaker operates at 12 to 24 volts DC from difficulty. Then how do they communicate with each other? The direct answer to this is not given in this video, but you will get a hint later. Friends, theory does not work in the age of skill and you yourself research on the internet. How much the market of 3D animation is exploding. We are also slowly building a 3D community where many animators are learning and sharing their experiences. If you are also interested in learning, then you are most welcome in our community. The details are available in the description. Now back to the point. So the high current of the city will flow through the relay, then the relay will operate. And the plunger in it will apply force to the outside side. Due to which the holding latch here will free the lever and the force of the spring loaded on the lever is coming, then the spring will pull this road downwards at a very high speed and the line will be closed. But it is not that easy. This high voltage line did not even leave the isolator, then how will the circuit breaker leave it so easily? When the spring comes down, a small gearbox is installed under the bushing. So that the three bushings are connected to each other, so that the force of the spring can reach all three bushings equally. When the spring goes down, the force of the direct spring comes on this road, which is called moving arcing contact. This road is insulated from the bottom and connects with the upper contact from above. So along with this road, the cylinder attached here will go down, but there is a piston in the cylinder which is absolutely fixed. And there is SF6 gas between this cylinder and the piston reach its pressure to 14.2 kilograms per cm2. As soon as these contacts are away from each other, a tremendous arc will be generated, but the piston will increase the pressure of the gas so much that the SF6 gas will come between these two contacts. SF6 is highly electronegative, so it will start converting into negative ions, which is heavier than electrons. So the arc generated between these two contacts will be eliminated. because its negative ions reduce its mobility due to heavy weight. So that all the free electrons will not be does not allow it to be converted into liquid. Because if the gas changes to liquid, then there will be no line break. For now, the circuit breaker is closed, but there is still a risk that the distance between the contacts of these circuit breakers is very less. That's why the isolator is installed after the circuit breaker, so when we manually turn off the circuit breaker to work on a line, then after turning off the circuit breaker, the isolator is definitely opened for double safety. Because when such a powerful line suddenly breaks, then there is a lot of stress, then the contact of the circuit breaker is very stressful. Because the current that was flowing at high speed so far will not get any path to go, then the current will reflect back from the contact of the circuit breaker. The way we stop the water flowing at high speed, then waves will start forming. This is exactly what happens with current, and this current is so powerful that the generator that generates electricity can also be unstable or damage any transformer. Many devices are installed to keep the devices behind safe. So generally the power transmission line is not broken until there is an emergency condition or a forced fault. You must have seen that our light goes away, but it is available in GSS anytime. That is because it is very challenging to break these lines. 132 kV or all the small lines can be easily broken with it, which does not make a big difference on the lines. Now it is not easy to connect the line again, which we have to come back to its mechanism to understand. The line is currently closed, one spring is also unloaded, so there is one more relay here to close the line, so this relay is given by the control as soon as it is free. The force of the closing spring is coming on this cam, which is still loaded, and it rotates this cam at a speed. The cam pin will apply force on the lever and the lever will load the spring on the side again, so that the line will be closed again. The spring that trips the line can only be charged by the closing spring, and there is a motor on the side to charge the closing spring. Then the spring will start loading again as soon as the circuit breaker closes. The opening and closing time of these circuit breakers is only 40 to 60 milliseconds. And if you stand near the circuit breaker while the line breaks, then the sound of the